Two men exert forces of F and P on the ropes. Determine the moment of each force about A. Which way will the pole rotate, clockwise or counterclockwise? So instead of the kind of usual equilibrium problem, this will be in motion. This will be rotating in some direction. And we're trying to see which moment created by either F or P will be greater. In the greater moment, it will rotate in either the clockwise direction or counterclockwise direction. So our find variable isn't actually going to be a number this time. Our find is going to be direction of rotation. Okay, so this is kind of what that would look like if moment caused by F is greater than the moment caused by P. Then I'll be going in the clockwise direction. And if the moment by P is greater than the moment caused by F, we'll go in the counterclockwise direction, counterclockwise. Okay, so as always, a diagram to start. And even though this is a problem that is in motion, we're going to assume that the pole is massless. There's no support really acting on it. There's just the support at A, but we're going to assume that it doesn't create a moment here. Okay, so we have point A and we only have a point A, I guess. It's the people labeled by B and C, but that's all right. So we know this is going to be 12 feet right here. This is going to be 6 feet right here. This point F, we're going to have force acting. It's going to be given by 3, 4, and 5 triangular components. Okay, and we know that F is going to be equal to 80 pounds. F is equal to 80 pounds. Okay, and then we have force P right up there. So see, it's defined by a 45-degree angle right here, and we know that force P is going to have a magnitude of 50 pounds. Okay, so now we have everything defined and labeled. Let's first find the moment caused by F. So moment caused by F will be equal to 80 pounds. And only the horizontal component right here will be creating a moment. The vertical component will not be creating a moment because it has no moment arm. Okay, so the horizontal component, we're going to find it by 4/5. Using that right triangle to find the horizontal component. And it's going to be acting at 12 feet from point A. If you plug that into your calculator, you should find that's a 768 pound-foot moment. Okay. And let's define the positive direction right here as being clockwise. And then we can compare the two magnitudes without a sign. Okay. And the moment caused by P. Moment caused by P will be equal to 50 pounds here. And only the horizontal component, again, right here, will be creating a moment because the vertical component has no moment arm relative to A. So only the horizontal component. Okay, I'm going to find that horizontal component by using the cosine of 45 right here. You could actually use the sine of 45 here too with the same value, but we use the cosine because it makes a little more sense. Okay, and we know it's going to be acting a total of 18 feet from point A. And you should get a moment of 636 pound-foot. Okay, and that will be acting in the counterclockwise direction. So if we take our two components, we see that 768 pound-feet is going to be greater than 663 pound-feet. So we know moment F is greater than moment P, and we look up here, it's me spinning in a clockwise direction. Okay, so we found our find variable. In this case, it's going to be a direction, not a number. A little different here, but that's it. We're done.